Now we're going to look at hard and soft water. So the key objectives for this part of the session, I want you all to be able to describe what is meant by hard water and what is meant by soft water, and describe what chemicals are likely to be dissolved in them to make them either hard or soft, and the pros and cons of each water type. Describe also what we can do to soften water and or reduce scale in boilers. So, like we've just sort of covered really in our objectives, we're going to sort of explore what's meant by hard and soft water in this part of the session. We're going to consider what sort of minerals or gases might be dissolved in the water to make it hard or soft, and to consider the pros and cons of each water type. So, pure water is pH neutral. pH is a scale that measures acidity or alkalinity, and 7's right in the middle. It's neither acidic or alkaline, it's described as neutral. So pure water, distilled water, has got a pH of 7. But one of the interesting things about water is it's extremely good as a solvent. It can dissolve all sorts of things, and that's why it's so great for making a lovely cup of tea, and you can stir in some honey, or you can stir in some sugar, or you can, if you're making your pasta, chuck in some salt, and all of these things dissolve into the water and are carried in solution. And water can dissolve lots and lots of different things, and what it dissolves can actually change the pH, can change the acidity or alkalinity of the water. You can actually check the pH level, how acidic or alkaline it is, by using litmus paper. If you dip litmus paper in and it starts to turn orange or red, then that means that the water will be acidic. Or if it starts to turn sort of blue or purple, then it means that water is alkaline. If you dip it in and it comes out green, then that means that the water is neutral. It's pH 7. Soft water has got dissolved gases in it normally, carbon dioxide or sulfur trioxide, and this would make it slightly acidic. And I always think it's good to remember soft water has got dissolved gases in it, hard water's got dissolved rocks in it, and we'll talk about that in a second. But all rain is technically acid rain, because all rain has got dissolved gases from the atmosphere, and it's going to be slightly acidic as it falls. When it starts to dissolve more pollutants and stuff, that's when you get some really serious acid rain, which then causes damage to plants and stuff. But all rain is slightly acidic, and acidic water would be known as soft water in the plumbing industry. If this rainwater lands on sandstone, it can't dissolve the sandstone, so as it's flowing over the sandstone, it will dissolve more gases from the air, and it will become even more soft. So if the rainwater lands on sandstone, it will become softer. If the rainwater lands on moorland, it will also become softer. And acidic water can cause corrosion in plumbing systems, and it can also speed up the electrolytic corrosion, like we talked about a little bit earlier in this module. On a positive note, it is good for washing with. The soft water doesn't react with any of the chemicals in the soap, so you actually get a much more of a lather, a much better wash, I suppose, with soft water. Hard water comes after this rainwater's started to flow over chalk or limestone, and then that starts to dissolve the rock, carry that rock in solution, and that then causes the water to become hard. It dissolves maybe calcium carbonate or calcium sulfate from the limestone or the chalk, and then that is then carried in the water, which then makes it alkaline. So hard water would be alkaline water, and there's two categories of hard water: temporary hard water, which is going to most likely have dissolved calcium carbonate in, and permanently hard water, which would have dissolved calcium sulfate in. The big difference between them, really, apart from obviously what rock's dissolved in them, is how they react when heated. Permanently hard water, the hardness wouldn't sort of precipitate out when the water's heated, but with temporary hard water, if you heat it up, then the rock will start to precipitate out and sort of fire up heat exchangers and sort of cause some issues of in the pipework. But one of the key things to know that, like I've said, the opposite of our soft water, hard water, temporary hard water or permanently hard water, will react with the soap before when washing, which actually means you need to use much more soap to get an appropriately decent sort of clean in a hard water area. Interesting fact though, there might be some health benefits to hard water because people generally live longer in hard water areas. Temporary hard water is the one that causes the most sort of damage to plumbing systems, it's particularly hot water systems. You can see here the heat exchanger from a combi boiler completely fired up the lime scale, and that's a result of temporary hard water. When you heat up temporary hard water, the hardness sort of precipitates out, the calcium carbonate precipitates out, and it starts to sort of fire things up, causing what we would describe as lime scale. This particularly is an issue when the water's heated to or above 65 degrees C. So, like I said, our hot water systems are most at risk from our temporary hard water. Like the coil in a cylinder, the heat exchanger in a combi boiler, all of these are places where they're likely to fire up, and it's likely to cause the system to be much less efficient because you need to heat up that scale before you can then heat up the water. So, talk very briefly now about softening water. Sitting gills quite often call water softeners water conditioners. It's worth noting. But the base exchange water softeners are the most effective water softeners. They use salt or sodium chloride. They mix it with water, and they keep that in what's called a brine tank, because salty water is called brine. And every night they will backwash this brine through the water softener. And inside the water softener, there's lots of little plastic beads called resin, and sort of the salt solution sort of binds onto the resin, and then as that hard water flows through it, there's actually a chemical reaction happens on the resin, which means that the calcium carbonate and calcium sulfate then reacts with the sodium chloride and that's on the resin, and essentially it makes the water soft. But like I say, every night you then need to backwash it with the brine, with the salty solution, to sort of recharge the water softener. It's not always a practical thing to fit, so what we generally do before all combi boilers is we would fit a scale inhibitor. A scale inhibitor isn't technically a water softener, it doesn't soften the water, it just stops the scale from happening, stops the scale from building up inside the heat exchanger. This is what we will most commonly see fitted before combi boilers. It's much easier and much cheaper to install than a base exchange water softener, for example. Okay, now it's time for your task.